Hello ladies and gentlemen, thank you for joining me for your MN16 notes where we're going to apply the tangent ratio. And I like using it for indirect measurement, which is the measurement of, let's say, the height of a tree, the height of a bridge, or, I don't know, for whatever reason, if you want to know the height of the Verona water tower. Rather than measuring it directly, we will use tangent ratio and ratios to measure things indirectly. To start with, let's just talk about where tangent ratios come from. As the directions in your note guide state, you want to place a point B on the horizontal axis, and you can put it anywhere on that horizontal axis. And you're going to use a protractor to create a 40-degree angle from that point B. So I'm going to come up here and create or get my protractor all lined up. Oops, let me try to get it all lined up. And find 40 degrees here. And draw a line going through point B, through that 40-degree mark, all the way up to what we're going to call point C. So I'm going to extend this a little bit, and this here is point C. So right here is my 40-degree mark. Now we're going to fill in, before we go any further with that right triangle, we want to fill in the blank words down here, adjacent, opposite, and hypotenuse. We've been working a lot with the hypotenuse, which is always directly across of that right angle. The other two sides we typically usually call legs, but when we're doing the tangent ratio, or later on with the sine and cosine, we are going to call this side the adjacent side because it is adjacent to angle B. It touches that angle B. And this is the opposite side because it is directly across from or opposite of that angle of 40 degrees. So down here it says side AB. That's adjacent to angle B. Side AC is the opposite side to angle B, and BC, as it says up in the diagram, is my hypotenuse. So then, coming down here, what you're going to do is you're going to pause this video and actually fill in this table. You're going to measure carefully, very, very carefully, in millimeters, your side of AC, AB, and then fill in the rest of this. Start the video, and we will compare our answers. Okay, ladies and gents, welcome back. You'll notice that when I measured my triangle up above, I got 59 centimeters from my length of my opposite side, leg AC. I got, for my adjacent side, AB, 71 millimeters. I created a ratio, which is just a fraction of those two lengths, 59 over 71, and then I converted over to a decimal. Now, the first three places in this table should not be the same as mine. Yours is going to be different. But what will be the same or similar is that 0.831. Like for instance, today my students were doing it in class, and one student got a 0.833, another one measured and got calculated a ratio of 0.821, and another 0.844. So really anything within that, that 0.82 all the way up to 0.85 is a good measure. There's variation, of course, because we are doing raw measures here, and there's going to be some variation in our values. But the whole point of this, which is really kind of cool, is that really the actual tangent of 40 degrees, which is what we calculated very concretely, you can use your calculator to find that ratio, this value right here. So if you use your calculator, you just type in tan of 40 degrees, hit enter, and you'll get that 0.831 or something very close. Or you can use what we call the table. And let me show you this table. I have it on another. Now you have the table in front of you, but here's my table. And you'll notice that here, these measures over here are your angle measures. This, oops, I can't write for whatever reason. Maybe I have to put it down. I can't write. But this is 40 degrees right here. And then this 0.831, which is, I'm kind of circling here, this 0.8391, that is the exact value for 40-degree angle, the opposite side over the adjacent side, the ratio. So kind of going back to my um, note guide here. So whether you use a calculator or the table, and that table you can find any angle measure for your tangent. It's been calculated for you in advance, but it's going to be 0.839. So what's kind of cool here again is that your right triangle is clearly not the same as mine, except for that you do have a 40-degree angle and you do have a 90-degree angle just like mine. But yours is either going to be an enlargement or a reduction of my triangle, which means then that we have similar triangles, but the ratio of those side lengths, opposite over adjacent, will be the same, that 0.839 to be exact. So I'm just that whole explore was just to kind of make sure you understand that this isn't magic. Really, the tangent itself, all it is the ratio of side lengths. So coming down here to this key vocabulary, trig ratio or trigonometric, I can't say that today, ratio is a ratio of two sides of a right, and it has to be a right triangle, And there are three trigonometric ratios. One is the tangent, which we're studying today, but then we'll also talk about the sine and cosine later on in further lessons. But the tangent ratio, as we talked about, is just the ratio of the sides, the opposite side to the angle that we're interested in over the adjacent side. So kind of reiterating what we talked about above. And really, the last part of this front page is just really hitting home on exactly what you really need to get out of this tangent ratio, which is if we're talking about the tangent of angle A, all you're going to do is, if you're given that side length, that opposite side length, which in this case would be CB, you would put that over your adjacent leg, which would be BA. And again, I'm just going to put a reminder that this is the opposite, this is the adjacent. So now how do we use this to find that indirect measure that I was talking about? If you flip your note guide over, we have three examples here. The first is more of, I always call it the ACT prep question kind of thing, which is also hitting home again on what we just talked about in the front, where if we want the ratio of tan of S, so S is right here, we know this is the hypotenuse. Directly across from the angle S is your opposite side, and adjacent to that is this right here. So the tan of S is going to be the opposite side, which is 60, over the adjacent side, which is 25. If you want to reduce that, and as it says, keep it as a fraction, and also then convert over to a decimal, rounded to 4 places. So you can divide, let's see, 5 goes into both of these, which is 12 over 5. That's your reduced ratio of your side lengths. And then convert it over into a decimal. It's going to be, as I'm kind of calculating it here, it's going to be 2.4000. Actually, it's a nice end rational number there. So these right there are the answers for the ratio of tangent of S. Now to find tan of R, that's going to be a little different. Actually, you know what I'm going to do? I'm going to switch colors here, because then you can kind of keep track of what the tan of R is going to be. Here's R right here. The opposite side is 25 now. See, that's different than the tan of S because, of course, the angles are not the same. So the opposite side and the adjacent side changes depending on what angle you're looking at. So 25 over 60, reduce that, that's going to be 5 over 12. And when you convert that over to a decimal, you're going to end up with 0.4167. So that is the tangent of R. Okay, so now, we've talked a lot about the ratios and so on, but let's actually find some lengths here, because that's kind of what we're interested in doing in the long run. So here we have the tangent, or excuse me, we have 31 degrees over here, and we want to know what the length of x is on that adjacent side. So again, we know that this is the hypotenuse. In respect to that 31 degrees, this is the opposite side, and this is the adjacent side. So tan of 31 degrees is equal to the opposite side, and I'm just going to remind you again, it's opposite over adjacent, so it's going to be 17 over x. So I'm going to solve for x, and this is going to be kind of strange initially, but remember that tan of 31 degrees is just a ratio. So right now, if you want to look it up in your table, you can, or use your calculator, but I like waiting to the very end to make sure it's as accurate, and I don't like writing all the decimals out at the very beginning. So I'm going to put that over 1 to make a proportion. And anytime you have a proportion, you cross multiply. We've talked a lot about cross multiplying, haven't we? So to cross multiply, just as a review, you're going to multiply those two values. So you have x times the tan of 31 degrees, and that's going to equal the cross of this, which is 1 times 17. Now this looks very strange, I realize, because of that tan of 31 degrees. But let me just kind of put it up here again, so I can show your steps clearly. 1 times 17 is 17, so I'm going to just write that. But to solve for x, we have multiplication here. So what we're going to do is we're going to divide just like we would typically do, and we want to get x all by itself, so we're going to divide out by the tan of 31 degrees. What we do to one side of an equation, of course, we have to do to the other side to keep it balanced. And what's kind of neat now here is these divide out. So we have x equals, and at this point you could just put in 17 divided by tan of 31 degrees in your calculator. It'll do it all at once, or 17, and I'm going to put that over what the tan of 31 actually is, which, looking at the table or using your calculator, it's 0.6009. You notice we use 4 decimal places always when we round the tangent. So when you divide out 17 divided by 0.6009, you end up with an approximate answer of 28.3 units. So this here is the way we use tangent to find a length. So kind of going all the way back to the beginning of what I was talking about with indirect measurement and finding the height of a very tall item. Let's say here we have a lighthouse, and we have the capability of measuring out from the lighthouse 100 feet, and we can use our angle measurement to find out that angle of elevation, which is elevation from the ground, that angle measurement, which is 62 degrees, and we're going to find that height. Now, if we're looking at that 62 degrees, directly across is the opposite side. Adjacent is the side right here. Remember, always across from 90 degrees is the hypotenuse. So let's find the height. Let's set up using the tangent ratio. So the tan of 62 degrees, the given angle, is equal to the opposite side, which is h, over the adjacent side, which is 100 feet. And again, just like above, I'm going to put this over 1 to create a proportion, which you cross multiply. Okay, so we're going tan of 62 degrees times 100, which is equal to 1 times h, which is h. Now again, you can just do this all right away in your calculator. Tan 62, enter, times 100, enter, and you'll get your value. Or you can say that the tan of 62 is 1.8807 times that 100. And when you multiply that together, you end up with that the lighthouse is 188.1 feet tall, which is a lot taller than I'd want to be up in the air. So this is a way of finding the height of an object without actually having to climb up and measure it directly. So thank you for tuning in. We'll go through any questions you have tomorrow in class.